Alright, so probably the hardest chapter, ACLs, access control lists. They are basically a firewall, right? And so they filter on layer 3 and layer 4 addresses, and yeah, they're great. I'm not going to go over everything we're going to do with IP version 4 and IP version 6 ACLs, and we're just going to jump way into it. And I'm going to jump clear to where the packet filtering, it says, we're going to do it layer 3 and 4, and to ACL operation. So we can filter, we're going to be filtering traffic, and so there's two ways we can filter traffic, inbound or outbound. And what that's going to be is we have this line, this interface, this is inbound, and this is outbound. Now this interface, this is inbound, and this is outbound. This is probably one of the hardest things, is to realize that inbound and outbound on different interfaces are different directions. And so we write these ACLs to filter traffic in a direction, and so if we write them right, we might not filter correctly if we write them correctly, even though because we have to place it inbound or outbound. So inbound happens before routing, right, as it's coming into the interface, and outbound happens after routing as it's going to leave an interface. And typically our best practice is we have two types. We have standard and extended. And standard is usually an outbound, probably, 8 out of 10 times. And extended is inbound, but it really depends on your network design. But hopefully we'll have that all figured out by the end of this. Oops. I did not mean to hit putty there. Sorry, guys. So we have standard ACLs, as I said before. Okay, and so standard ACLs only filter on source IP address. So if you're in the source IP address, you're allowed. They're more commonly used with like NAT, DHCP, stuff like that. Or not DHCP, but NAT. And so, yep, just the source address says if you have the source IP address, you can go. For extended, they filter on a lot of things. Okay, so they filter on, if we look here, protocol. So what does the protocol mean? First we say access list 103 permit, so this is allowing this protocol. TCP, so we can do TCP, UDP, IP, ICMP. IP means all of the IP stack. ICMP is just ICMP. TCP, we're going to pick some port numbers. UDP, we pick the port numbers. I can't think of anything else they have there right now. Okay, so then we filter on protocol, and then the next thing is the source IP address. And as you can see, access lists are written in with wildcard subnets, so it's a wildcard subnet. And then the source, and this is an any. This is one of our words that we can use. We can use host, meaning just this one computer, which we do here, except this is the entire network. And then any means any computer. So anything that tried, anywhere it wants to go. This network can use TCP equal to 80 anywhere it wants to go, right? So TCP equal to 80. Hopefully you guys remember your port numbers. 80 is HTTP. It can be worthless in this day and age, but that is some of our options. There's other things we can put on here, like after it's been established. So if we ask for a connection, we would allow it to come back in only if the inside network asks for a connection, stuff like that. But there's other options, but we're not going to go over advanced options, I don't think. So our first type of ACL is a numbered ACL. So we have standard and extended, right? So in those based on how we filter, but they have number ranges. So 1 through 99 and 1300 through 199, 1999 are standard. So what that means is if we go back, you guys can see this is a numbered ACL right here, and it's 10, right? So it's 1 through 99. And so it only has these options. If we wrote a numbered ACL, and numbers ACLs don't start with IP. Named ACLs start with IP. Numbered ACLs start with access list. And so we can go into config T and just start writing this, and that's an access list. Where extended ACLs have to be over 99. So starts at 100, goes to 199, and then the extended ports are 2000 to 2699. Alright. So a named ACL can only contain alphanumeric characters. It is suggested that a name can be written in capital letters. What? Names cannot contain spaces or punctuation. Either can be added or deleted with the ACL. Sure. I don't know what it's trying to say, but we'll keep going. They must be talking about descriptions. So, back to these wildcard masks. If you did not understand wildcard masks, right? So it's the inverse of a subnet mask. Like, if you have a /24, it's going to be 0.0.0.255, right? Okay, so that's our /24. Typically, or in the days of past when we just write a subnet, a /24 is 255.255.255.0. So it was the inverse of that, right? And how do we get it? We subtract it by 4 255s, right, to get what we need. So if you're having trouble with that, take a look at this stuff right here. We're going to keep moving on to our ACLs because they're too much fun to dwell on the wildcard masks. Alright, so the 3 P's of ACLs. One access list per protocol. So we can write an access list for IP version 4 and IP version 6. One access per direction. So we can put one IP version 4 at one IP version 4 address in, one IP version 6 address in. We can put one IP version address out. Actually, this is the out IP version 4, sorry. This is the in IP version 4. And one out. Okay? And one per interface. So one interface can have 4 ACLs. Okay. Yep. And that's basically what they're saying there. ACL best practices. I don't remember if I mentioned this or not. Alright, let's see. Base your ACLs on the security policy of your organization. Oh wow, never would have thought of that. Prepare a description of what you want your ACL to do. Oh, okay. Let's start like writing on paper here. Use a text editor to create, edit, and save ACLs. Good idea. Test your ACLs on a development network before implementing them on your production network. That's because if you write your ACL wrong, you could probably knock yourself out to where you had to console into your device. So that is extremely good advice. This benefit, anyways, you have a library, yeah. I also have another suggestion. If you have someone else to look at ACL, ask them what they think too. Another network guy, not just some person, I guess. But it's always good to have more eyes on an ACL, and that's why you need to write down what you're preparing to do and why you're writing an ACL. Because, yeah, ACLs, when they work, it's great, but a lot of times you're spending time on Wireshark or somewhere trying to figure out all the protocols you need to allow to make the ACL work. So where to place ACLs? So typically, I don't know, we'll say 6 out of 10 times, maybe 8 out of 10 times, I don't know. Standard ACLs are placed out, while extended ACLs are placed in. Actually, we're not even talking about that placement, but when we assign. Because what we want to do with an extended ACL is place it as close to the source as possible, because it's going to filter a lot of stuff. So we want to place it as close as possible, or we want to place this one as far as possible, right? So if we're just blocking, I don't know, if we're like, actually if we're blocking these networks over here, we want to block it here because we still want these devices perhaps to get to this router. So yeah, that's our placement. Standard, close to the destination as possible. Extended, as close to the source as possible. So hopefully that's what it said. Anyways, type ACL may depend on the extent of the network administrator's control. Right, if only control a certain place, that's where our inbound and outbound gets confusing. Like if we could just say hey, but inbound and outbound is determined. Like if I only control this side, I can only place it, like especially if I'm trying to place it close to the destination. What if the destination's over here? So we don't always get our best practices. The bandwidths of the networks involved. Maybe like if we're blocking this guy, this network from going everywhere else, we want to block it right there, right? Because that way it doesn't waste CPU, and we don't want to waste all this stuff, like it going places it doesn't need to go, and we're just going to block it. And then use the configuration. I don't know. Yeah, so if we want to, sometimes if we want to block a lot of networks, maybe we place it a little further away, or place it a little close. I don't know. Stuff like that. Anyways, just know that really read over this stuff, because having a strong understanding of ACLs, there are a lot of ACL questions on the CCNA. So just make sure you have a strong understanding. So standard placement, extended placement, just kind of talked about those, so you guys can look over that. But I'm gonna keep moving on. Alright, so entering criteria statements. We do it in global config, as I said before, and so they're still writing numbered ACLs, right? So you see access list 1. Okay, so that's our first statement. Then right here, access lists by default have an implicit deny, meaning they deny everything. So it's rare to see a deny statement like this, because that's actually, this is oxymoron. This is actually what's written into the ACL. So the only time we deny is if we permitted everything and we just want to deny one thing. And so, which is the opposite of what most ACLs are used for. So this one, access permit 10.0.0.255. Okay, so this is actually the same ACL as down here, right? And what it's going to block, like it's going to allow, if we allow it first and then deny it, it's a list, right? So it goes down the list. So if we allow traffic, it's going to go. So if we allowed this and then said deny right under it, it's going to allow. So if you ever get a question like that, you go down the list, and the first one on the list it's going to do, and as soon as it's done that, the traffic's gone. You can't then deny it again. But these are actually the same exact list, just with the oxymoron command that's built into any standard access list. So if you want to know the command built into any standard access list, it's not this 2, right? It's the deny any. So that's what's built into a standard ACL. They filter on source network, source IP address. So we say, hey, if you want to allow these IP addresses, do it. So let's see if they have a straight. Here's what we can do. We can do a remark. The remarks are like notes. Permit, deny. Okay, it's either allowing or denying. If we put a log on, what it does is if we have our console cable in or do a show log, it will log the block content or whatever the statement is. So such as if we have access list 10 permit this network 192.168.10.0.255 log, it will say every time that someone is permitted for that. So if we wanted to keep this in our syslog server, we would have a list of every time that this person was allowed to go somewhere. Where this is nice is when we go into extended ACLs, if we wanted a really bad log of all the IP addresses people are going to, we could do it. And it would bog down your syslog server for a lot. It would definitely do a lot of traffic, as every time somebody went there it would log it, but that's where our command is. But to write them, as you guys can see, we just put the number, say permit or deny, usually permit, right, because it's implicit deny. So unless we said permit any, then everything would be allowed. Then we'd say access list 10, deny. So like this, we could say AC access list. I'm sure I'm gonna try to tab here, and it's not gonna work. Access list 10, permit any. That permits everyone. All right, and then we'd say access list 10, deny 192, or we could even do host 192.168.1.1. Alright, so that would block only the host 192.168.1. If I wanted to block that entire network, and we'd say it's at a classful, we'd say 192.168.1.0.0.0.0.255. Okay, so that access list would only block this network. Everything else would be allowed after I put it on an interface. And that's how those work. So hopefully that helped if you weren't understanding it. But make sure you really look at this. As you can see, they put a remark on it. Access list 10, permit hosts from the 192.168 chain.0.lan. It's just a little note to put in there. Remark. Yep. Internal logic. This is what I was talking about when I said it was a list. So as you can see, they permitted host 10.10 and then they denied. And so the 10 network. So the host 10.10 would actually make it, and then the rest of the 10 network would be denied, and then everybody else would be denied based on this ACL. So it's a list. Now, it just goes down the list. So that's whenever you see ACE, that's what it's talking about. So that was named ACLs. Now they're going to start talking about, well, I don't know why they're doing this. Oh no, they're not talking about that. They're going to talk about named ACLs, but numbered ACLs. How do we apply them? So we made our access list. We put our permit commands, right? Or our deny commands. Now we go into our interface. We say interface, F00, and then we say IP access group. Okay, so IP access group is on an interface, I believe. Yep, IP access group. And our last one, what was it, 10? So that's the number of the access list, right? So the access list number is kind of its name right now. Or not kind of, is its name right now. And so we're saying IP access group 10, saying access list 10 is applied to this access group. And we say out, meaning outbound. Or we could put in, meaning inbound. Okay, so if we want it going out of it, filtering on the outbound of an interface or the inbound. So we go in the interface and apply it to the interface after making the access list in the global configuration, as you guys can see here. Anyhow, they just did an incoming there instead of an outbound. What do we have now? Creating named standard lists. Okay, so now we have a named. So before, oops, yeah, no, that one was right. But when we were making those numbered, we said access list 10, okay, and then permit 192.168.1.0. We'll say we do a named access list. A named access list is easier to modify. It's all numbered. This one is too. It used to be you had to delete the whole access list. I never used numbered, but I don't believe you have to delete them anymore. You can actually enter each line. So if you made a 300 line ACL, you can pick which line to go into. And how that works is it spaces the lines out by 10, so you can put 9 lines in between each one, each command you initially had. So if you want to change it, modify it a little bit, you can. But to make a named, you say IP access list. Oops. And then instead of that, like, say I wanted to make for a VLAN, I could say VLAN 10, and this is how I always make my ACLs, because it actually tells me, like, then when I apply, I just say, oh, where am I applying this? Oh, for VLAN 10, okay, I'm going to apply it to VLAN 10. So IP access list, VLAN 10, permit 192.168.1.0. Okay, which one's easier? I don't know. But actually, I guess you press enter after you name it, and you say IP access list standard, meaning it's a standard access list, and then the name. Let's see if that's right. Yep. So we could do extended here if we wanted to make an extended. And the same thing, then we'd have the extended options, but as we put standard options, that's all we're doing. And we could put remarks on that and all of that, and that's what they're showing you here, right? A named IP access list standard, no access. They're blocking a host, and they're permitting all the hosts. So look at, as I've been saying, they did permit any, so they only want to block one person. So it's the opposite of what an access list is. Usually you want to only allow who needs access, right? Access is on a need to use basis, not on, hey, anybody can just run wild. Commenting, the remark command, as we've talked about. So now let's get to editing standard ACLs. Okay, so standard numbered ACLs, we just delete. If you look at what they're doing, they're just deleting it, taking it from a text editor, putting in what they want, and pasting it in. Now if it was named, we wouldn't have to. We can do show access list 1. You see how it's spaced out by 10? It shows what we're doing, and we could add lines in between there. But they're doing IP access list standard 1, as in this is a named access list. I guess you can create the access list like this and then go into a named version of it, since it's actually named 1, and do all the named commands. And so the named commands, what I'm trying to say is, doing it by numbered is a lot harder because they're just statements, whereas we actually have like an access list editor when we do the IP access list command. We do have to say standard and that, but there's 2 ways to edit, even if they're not named. So the named ones are easier to edit, but we edit the number just like we edit the names. How do we see our access lists? Show access list command, and it lists all of them, and it lists, like, if you have long ones, it shows it shows just like this, just how they're listed. And so if we wanted to edit a number, I hope what you guys are understanding that I can go right here. So I would say, hey, I just want to put some more stuff in. So in between line 15 and line 10, or why is 15 up there? I don't know. They have something weird going on. But I could be like, alright, so I want line 11 to say something else. I want to allow well, their commands don't even make sense here. Oh, they're just denying 2 people. Alright, so I want to deny one other person right here. I want to deny 192.168.11.12. So I could put that in by putting line 12 in. And what I mean by line 12 is, if we go back to editing, right, this 10 number, so that's 10. I put 12 inside of the specified standard ACL editor, right? Put 12, permit, deny, whatever I want to do. Put it in there. That's how we edit them. ACL statistics. So when we do the show access list, if you ever see something like this, it means that it has denied 8 times, it's denied that, right? So as it's been operating, it shows you the statistics. Another way to see these, you do show running config. I don't know. So then implementing a standard ACL, or I guess you could do extended. It's usually a standard if we want to lock down telnet. So we just want the IT department to get in telnet. Remember to apply before we did went in the interface F0 1, and if I was doing the top ACL, the named one, I'd say IP access class VLAN 10 in or out. We'll go out with that one. Then if I'm doing telnet, I'd go interface VTY 0 space 4 IP access class VLAN 10 in. So that would only allow 192.168.1.0 to telnet, and that's one place where standard ACLs are often used, is on V2Y lines. So go ahead and take a look at those VTYs if you don't understand what I'm saying. And so now we get to extended ACLs. So extended ACLs, because they have so many more things, they're quite a bit more confusing, right? Because we can filter on protocol, source address, destination address, port numbers, right? Before, standard ACLs, one address, source address. That's it. That's all we had to worry about. Now we're worried about all these other things. So how do we write them? Go back to here. These are all gone. So first, they have to be above 100, right? So we can go access list. I'm just going to go 101 because it sounds, oop, and it's a dash. Access list. 101. Permit. Then we put a protocol. So right here, if we want to do similar to our standard ACL, it's IP, right? Because it's allowing the entire network. So this is everything in the pipe, the TCP, the IP, all that stuff, the IP stack, all of it in this network. So I could say IP allow 192.168.1.0 to any network, or to only this network, 192.168. Oops, I forgot my wildcard mask, so I go 0.0.255. And then I say to the network 192.168.2.0, and then that's it with IP. Alright, and so what I'm doing here is, this is the protocol, and we'll go back one. This is the protocol, right? One more. Oh, just spacebar over there. This is the source network. That's the wildcard mask for that. That's the destination, and I see that I forgot this. Subnet mask again, or wildcard mask. 0.0.0.255. Okay, so that's the destination network. So that's one way to do it. Then our other way was we could copy all the same things, right? We could go, alright, we're going to write the same access list, except this time we wouldn't want to do both of these, but now we say permit TCP for 192.168.1.15, and we'd actually say host, right? If we want to do one, we'll just do the entire network, but if we want to just do one host, we just say host 192.168 0.0.0.255 to 192.168.100.0 equal to, oh no, we gotta put their network too, 255 equal to 443, right? So so we can do HTTPS. That's what we're trying right there. Okay, so now we have protocol, source network, and then destination network, and then we have the port number. Then we could also do, if we didn't want to do that, we could also put a port number right here. We could say equal to 443 here to 443 there. So this is the source port, which this doesn't actually make sense anymore. Or yeah, this is the source network port, and this is the destination port. So we can do different things like that. So hopefully that helps you as much as any of these, right? But take a look at this, and so they're not even using port numbers down here. They say equal to telnet, FTP data. There's certain hotkeys you can do, but if you look up here, it's the exact same. They did port numbers, and if you did a show ACLs, it usually does the letters rather than the numbers. Configuring, kind of talked about that. Watch that again. Another thing we can do is then we say after the port number we could say established, and that's what I think I talked to you guys about that. It means if this was requested, then it's allowed. Like if it's only allowed after this guy requests a 443, or if let's say we did it the other way, equals 443. We took this out. This wouldn't be able to request 443 unless this requested. Well, I guess we don't have a port now. Requested something from this network now. Okay, that's how that works. How do we apply them? We apply them the exact same way as standard ACLs. Take a look at these graphics if you didn't understand it with standard ACLs. But this is why these are doing the traffic filtering, right? Like standard filters networks, extended filters protocols. Make sure I would do some of these worksheets on here if we find one towards the end, because usually there's a CCNA where you have to block web traffic from everybody but one host, which would be a simple one command thing, right? Like you just do. Like if you just want web traffic from one person, you say permit, and we'll say that one person is, actually we'll go, I don't know, we'll write it like this, IP access list. So this is a named one now, right? Because it starts with IP rather than access list, rather than a number. And I say extended right here, and I say VLAN 100 now. So that's the name. I'd press enter. This would go into specified access control list mode. Now I'd say permit TCP. So I start with my protocol, right? Then it's my source network, 192. And I'm going to do just one host. Host 192, 168. 100. Nah, I'll just do the whole number. Nah, we'll do two. 192, 168, 100.0. And so then I don't have to put a wildcard mask because it's saying that it's, and that's not a good one probably. So we'll just go like that. So host 100.1 can go to the destination of host 200, 192, 168, 200.15 equal to port 80. So you can do HTTP. So that's a common kind of thing that they have, that you just have to figure out. Then you have to figure out how to place it correctly. But you can always, whenever you do this, try it in Packet Tracer, make sure it works how you think it will. Like, don't just write the access list, test it, right? Just like you would test it in a practice network or in a test network. Test it. Don't just submit it if you're taking a CCNA or something like that. But what's actually being, if you wanted to see the command that's at the end of every extended access list, remember deny any was the command for standard ACLs, but deny IP any is the command for extended ACLs. So if you're ever wondering, that's the oxymoron command to write at the bottom of it. It doesn't need it if you just have permit statements like that. So yeah, how do we verify them? Show access list same way. Edit them in the same way as we do extended, it's just they're longer. So access lists are similar. Let's see, what else do we have? Troubleshooting ACLs. We have a bunch of labs. So these are the labs I'm talking about. Hit all of these access control list labs because it's going to do nothing but help you. So on the troubleshooting, just talk about the ACE. So what it's saying is it goes down the list, right? Trial 1, trial 2, trial 3, right? Permit or deny, permit or deny. Anyways, take a look through there. It's pretty common sense. Then there's some common ACL errors. Take a look at those. Now we're going to go to IP version 6 ACLs. There's a slight difference on the IP version 6 ACLs. They're named only. Okay? We cannot do just a numbered ACL. And they all function similar to extended, I guess. There's no wildcard mask, right? Because we do the slash just like we did before. So if we did that, I don't know, we could go like IP, well, we do PV6, right? Access list instead of IP version IP, right? IP just means IP version 4. Access list, we'll say, I don't know, 10, and we're going to permit 2001 DB8 CAD 1::/64. Alright, so we permit that network. That's how we're going to do it. So they're exact same, except we write them like that. And the one difference is at the very end of every, they don't have just implicit deny, they have the permit IP, ICMP, any, NDA, NA, permit ICMP, NDA. So neighbor solicitations and neighbor advertisements. So remember, that's ICMP and how it does, like it's link local stuff. If you don't remember, it's the Slack stuff and all of that really fun stuff. So IP version 6 ACLs have that at the end of them. Go ahead and take a look at those, but spend some time on them. Maybe try the FTP denied. ACLs, can't stress how important they are, so please try all the extra stuff in this chapter. It will really help you out. If you have any questions, please send me an email.